Hello guys, I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So today we are going to see the solution. As you all know that अभी ESC mains paper हुआ है 2023 का. So I am going to take all the questions which were asked from strength of material. So we will see the solution of all the SOM questions from mechanical engineering paper. Okay. So we are going to start it. Total of 4 questions were there in that. Let us see. So guys, this is some detail about me, and now we are starting the question. So this is the very first question, and this question is basically from the torsion. If you see, this was the first A part. You know, this is the compulsory question. Question number 1 in part A, question number 5 in part B are compulsory question. So it is a circular bar ABC 4 meter long is rigidly fixed at its ends A and C. Okay, so we are given that we are having end A and end C. They are to be fixed. Okay, and they are saying that AB is 2.8 meter long, 50 mm in diameter. BC is 1.2 meter long, 25 mm in diameter. It means we will be having here, this is going to be like this. This is 2.8 meter. And diameter is 50 mm. And second part is this. This is 1.2 meter and 25 mm diameter. And my dear, then they have said the twisting moment of 700 Newton meter is applied at B. Obviously, this will be the longitudinal axis. This will be the point B. And here we have a torque. They have not mentioned the direction. They have just said 700 Newton meter. So this is the twisting moment applied. And they have asked determine the values of the resisting moment at A and C and the maximum stress in each of the section. And they have given the value of G to be 80 giganewton per meter square. So guys, first of all, you will see all the given things. You will write all of those things like I have made the diagram. Then you will be assuming there will be a twisting reaction TA, and here also we will be having a reaction TC. So now my dear, you can write TA plus TC is equals to T. This is one equation. Here you may be thinking about that, sir, can we use the shortcut? No, shortcut is not useful because here J is variable, G is constant, so product of GJ is variable. So my dear, this is TA plus TC is equals to T. And if I consider this to be 1, this to be 2, then you can also write theta 1 plus theta 2 is equals to 0 because it is fixed at both the ends. So these are the two conditions. So you can write T1 L1, G is constant for both, GJ1 plus T L2 GJ2, that is equals to 0. So my dear, now when we are talking about T1 and T2, for that we need to apply method of section. If you will take a section here and here, you can write T11 as equals to TA, okay, and T22 is equals to TA minus T. So we are going to use it. This is T, 700 Newton meter. So my dear, now we are going to apply this. We will be writing TA L1 is 2.8. Okay, G is given as 80 into 10 to the power 9. And J is pi by 32, 50 ki power 4. That is equals to minus, because when this term will be going on the that side, it will become negative. So it is T2 is TA minus 700 into 1.2 divided by, this is 80 into 10 to the power 9 into pi by 32, 25 ki power 4. And my dear, if you want, you can convert this meter into mm also. Okay, why? Because everything is in mm you have taken. But even if you do not do that, you know, both the sides they will get cancelled out. Okay, like if you multiply it with 1000 to convert it into mm, so that doesn't matter, because here also you will be doing the same thing. Similarly, here it is in Newton meter, you can multiply or not, because both side you will get answer in that way only. So when you will be solving it, my dear, this will give you the value of TA. And as I have already solved it for you, I have done calculations. But guys, as I am saying, calculation wise, students are always good in calculation. When we were student, we were good in calculation. But as with the teaching, the habit of calculation is not there. So I have done it, but be cross check it. Okay. So if you see this, TA will be coming out to be around 610.9 Newton meter. From the second equation, which is TA plus TB is equals to T, you can get the value of TB as it will be 89.1. 89.1. Yes. These are two values. Now, my dear, you also need to find out the maximum stress. So, you know, in the first, this is TA. So, you can write down the tau max in AB. Tau max in AB. That will be equals to T11 upon ZP, or T11 into R1 upon J1. So T11 is 610.9. It is 25 mm divided by pi by 32. It is 50 की power 4. This will give you tau max AB as 24.89 MPa. Similarly, you can apply this onto the second shaft, tau max BC, T2 by ZP2, or T2 R2 by J2. Putting these values, T2 is 89 points, okay, 89.1. 89.1, na? 89.1, okay. Into R2 is, diameter is 25. Diameter is 25, yes. So it is 25 by 2, pi by 32, 25.4. So when you will be solving it, you will be getting it to be 29.038 MPa. So guys, this question was asked in 12 marks. So in 12 marks, they have asked about these, this and this. So I feel 4 should be the marking scheme. So let us move to the next question. This is from the deflection of beams. Here this question is a part of, not a compulsory question. Find the slope and deflection at the tip of the cantilever shown in the figure. What load P must be applied upward at mid-span to reduce the deflection by half? So my dear, first of all, you can say that we are having this on which a UDL was acting like this, and along with that you applied a point load. This is 30 kilonewton and this is 20 kilonewton per meter. And they are saying then we will be applying, okay, let us say when this is the loading condition, we will be finding out deflection at A will be maximum. You know, in cantilever beam, maximum deflection occurs at the free end. So you will be getting, let us say YA is something Y. Then he is saying when I will be applying, this loading is there, along with this, I am applying a P load which is unknown at a distance of mid span, and after that the deflection at A will become Y by 2. So you need to find out what is the P value for this. I feel till this whatever explanation I have given, इससे आप लोग समझ गए होंगे कि here we are going to use the principle of superposition in deflection of beams. So my dear, first of all we will go with this. Let us say we have a UDL. So everybody know that because of UDL, if this is A, this is B, deflection at A will be minus WL4 upon ATI. Similarly, if we are having a point load at the end, then deflection at A can be written as minus PL cube upon 3EI. Okay, so it was a 20 marks question actually. And my dear, if you want, you can find it also by the double integration, but then it will become very, very lengthy. So these are the two things. And then my dear, the third thing, if you have this, we are considering as P1, let us say, because this is P1. So we are, this is P, because this is given as P, so we have considered it as P1. So my dear, because of this also, you know, principle of superposition, this is AB, L by 2, L by 2. Why this is L by 2? Because this is 2 meter, 2 meter. So you can write down deflection at A will be equals to, as it is going to be upward. So we will say, you know, after this it will be a straight line, because there is no load between A and B. So if you want to find out deflection at A, it will be deflection at B plus slope at B into AB. This is also principle of superposition. And you know, theta at A and B are going to be equals. Why? Because there is no bending moment between A and B. And if bending moment between A and B is 0, as you know, M upon EI is equals to 1 upon R. So when M will be 0 from A to B, R will be infinity. For that, it will be a straight line. So my dear, you can find out deflection at A. This will be positive. So it is minus P L by 2 cube upon 3I plus. Okay, now this is minus, no, this is plus, because it is upward. So here theta, if you see, theta, if you will find out, that is also going to be anti-clockwise. So plus P into L by 2 ka square upon 2EI into, this is AB, not AB, it is, this is C now, so AC, AC, okay, this is C actually, this is B. So my dear, this is AC, AC is L by 2 again. So AC is L by 2 again, you will put the value, you will get it here. So what he is saying, initially we have these two loadings. So initially you will be having deflection at A will be equals to minus WL4 upon 8EI minus P1 L cube upon 3EI. But when this is added, the deflection becomes half. So you can see, if you will be adding all of them, deflection at A is minus WL4 upon 8EI plus, sorry, minus P1 L cube upon 3EI. Everybody know why we are keeping it P1? Because given load is P. So now plus, what is plus? Plus this thing. It is P into L by 2 ka cube 3EI plus L by 2 square 2EI into L by 2. So when you will be adding this deflection into this deflection, it will become equals to half of minus WL4 upon 8EI minus P1 L cube upon 3EI. So my dear, when you will be solving, everything is given to us. If you see the numerical, W is 20 kilonewton per meter. Length is 4 meters. And P1 is 30 kilonewton. EI will get cancelled out throughout. So my dear, when you will solve it, you will be getting the value of P as equals to. So I have already solved it for you guys, and after solving, we are getting the value as 96 kilonewton. Once again, as I said guys, you guys are champ in calculation, okay? So I have tried it for you, but yes, procedure will remain the same what I have said. So 96 kilonewton. This was a 20 marks question, okay? 20 marks question. Yes. Then my dear, moving to one more question. It is from SFD BMD. Here we need to find out the maximum bending moment. So my dear, in this question, if you will see, they have given a simply supported beam AB a bar CD is welded. This bar CD is welded. And they have said after determining the support forces, sketch the SFD BMD and determine the maximum bending moment. Okay. So my dear, if you are going to talk about this, first of all, your task will be to find out the support reaction RA and RB. RA and RB. Before that, you need to see the effect of this force 5 kilonewton. You will apply 1.5 here, 1.5 here, and this will be making a couple which is going to be like this. Okay. So if you want to write down the RA, you can use the shortcut. You know, here also principle of superposition. Because of this 10 kilonewton, you will say RA upward, 10 kilonewton downward. So side will be plus 10 into distance from opposite end is 16 meter. Total length is 24. One thing. Then my dear plus the effect of UDL. UDL is 2 kilonewton per meter for 8. So it is 16 kilonewton. And it is upward, it is downward, side will be plus. And UDL are generally considered at the midpoint of theirs. So distance will be 8 plus 4. Opposite end distance will be 12. Total length is 24. Then this moment, my dear, moment is 5 into 5, okay, 5 into 2 into 0.5. 5 into 0.5. It will be 2.5 kilonewton meter. So you will be saying this to be, sorry, plus. You know that this moment and moment created by RA have same direction. So it will be minus M by L. Minus 2.5 divided by total length is 24. So these are the summation of 3 and 3 components. This 5 will not contribute anything in the horizontal reaction. It will directly create a horizontal reaction here equals to 5 kilonewton. So my dear, you will be having this reaction. So RA we will be getting as 14.5625. Then you also know RA plus RB. RA upward, RB upward, that is equals to 10 downward, 2 into 8, 16 downward. It is equals to 26. So it will give us RB also. RB we will be getting it as 11.4375. My dear, although we can make this SFD BMD very easily from the techniques of slope method, but in conventional paper I always told you that go by the calculations. Okay, because in conventional method you need to go by the calculations. So now we will be first of all making the diagram, loading diagram. This is RA. This is RB. Divide the beam into 3 parts. 8 meters, 8 meters, 8 meters. You are having a load here, a UDL here, then a horizontal load here and a moment here. This is 2.5. This is 5. This is, and this is 10. So my dear, first of all, as support reactions calculations have been done, you will go for shear force calculations. I feel now you would not be interested into the way, into the complete procedure, because you know that now you want only the solutions, because that paper you have already attempted. So if you go by that, I am just making the sign convention here. This is positive shear force, negative shear force, positive bending moment, negative bending moment. So my dear, you would be having a upward jump. If you see the left hand side of the section, upward, left hand side upward is positive. You will have a jump of how much? 14.5625. This is 14.5625. Then from A to this point E, there is no other load. After that, there is a jump of 10 kilonewton, and you know section is valid only before E. Next section will say to the left hand side downward is going to be negative. So you would be having a jump in the downward direction up to 10 kilonewton. So this will be 4.5625 kilonewton. After that, my dear, you can also start from the third section. That will make things easier for you. To the right hand side upward is negative. So you would be having a jump of equals to 11.4375. 11.4375. There is nothing till this point. And in between you have UDL. So for UDL, you would be having inclined line joining these two. Okay. So even if you want to write down the shear force equation, this is section 1-1. Then I can write V11 is equals to plus RA, valid from A to E. Then if you want to write down 3-3 minus RB, B to C. If you want to write down V22, this is 3-3, this is 2-2. Then you would be having plus RA minus 10 minus W into X, and yes, it will go up to E to C. This point is C. Okay. So now, my dear, you can put the value and get the answer. This W is nothing but the 2 kilonewton per meter. Okay. So, my dear, you need to find out the point where shear force is changing its sign, because this is the point where we will get bending moment to be maximum. For that, you need to equate V22 to be equals to 0, and that will give you X value to be equals to what? It will give you the X value as it is 10.28 meters. Okay, so this is 2.28. This is SFD. Now, when you will be going for BMD, you can go in the same way. You know, initially, if you will go for bending moment calculation, M11 will be simply RA into X, because it is creating sagging. Similarly, M33, RB into X, because it is also creating sagging as per the convention. So, my dear, this is horizontal line, 1 degree more will be inclined line. So you would be having here, diagram will be coming like this. Here also. Here also. Okay. So, my dear, now, if you see this value will be coming out to be what? RA into 8. This is valid from A to E. So you can find out bending moment at A will be 0. Bending moment at E will be RA into 8. What is that value? That is 116.5. Then, my dear, for M33, you can write MB is 0 because X is 0. MC will be RB into 8. That will be 91.5. Okay. Then, my dear, here you have a jump. Here you have a jump because of this bending moment. And if you see, this is creating sagging, this is hogging. So jump will be downward or upward? It will be downward of 2.5 kilonewton. And in between you have inclined line, so it will be a parabola. And you can see initially shear force decreasing, then shear force increasing. So initially slope will decrease, and then slope will increase. So this will be the BMD. And if you want to find out this maximum bending moment, my dear, if you want to find out this, for that you can write bending moment maximum as, this will be RA into this 10.28. minus 10 into 2.28 minus W into X into X by 2. This will give you the maximum bending moment, and that is 121.704. Okay, this is it clear for everyone? So guys, I have tried to calculate for you. So for calculation, you can check once again, but it is correct only because I have done it and tried it. Key, it should be correct only, but calculation wise, if something you find also, you can tell me. Okay, but otherwise the procedure will be remaining the same. As I said, when you will attempt the paper, there you will not do like that only. You will be writing these equations properly. Like bending moment 2 equation, when you will write, it will be what? It will be RA into X minus, then 10 into X minus 8. Then W is 2 into X into X by 2. And in this equation, we are putting X is equals to 10.28. Then you will get the bending moment maximum. Here you can see this is parabola X ki power 2. So like this you will be solving. So I know, but you have attempted the paper, for you only it matters that what would be the answer and how the solution will be. This is going to be the way of solution, because the guidelines how to attempt are useful in the starting before the exam, not after the exam. This is the last question from strength of material. Theory of failure will be counted in machine design as per the syllabus, and stress strain diagram will be from the material science, because they have asked the properties. Properties part is there, given there. But that is also theoretical. If you want on that, already videos are available in this channel based on stress strain diagram. This is a good question, 20 marks. A T section beam 100 mm wide. There is a T section beam. $100 wide and 150 mm deep with 150 mm deep. Flange thickness is 25 mm. Okay, then this is 12 mm web, and this thickness, this length is 125. So my dear, when you see this question, they are talking about bending stresses. So to talk about bending stresses, we need the centroid first. So first you will be finding out the centroid. I am considering this to be the origin. So you can consider this as 1, this as 2. And you can find out the centroid positioning as A1 Y1 plus A2 Y2 by A1 plus A2. So you can write first area is 100 into 25. Then you can find out the Y1. You are taking from origin, from 0. So this will be 125 plus 12.5, 137. Okay, I have done it for you. And yes, this is plus. Second area is 12 cross 125. This is area into distance will be 125 by 2 will be 67.5. Yes, I have done it for you. Yes, 62.5. Then you will be having A1 plus A2. 100 cross 25 plus 125 cross 12. This will give you the Y bar. And Y bar is coming out to be 109.375. So my dear, this distance is 109.375. So you can also find out this distance. And this distance is nothing but 40.625. So now my dear, let us see the question part. They are saying if the limiting bending stresses for the material of the beam are 80 and 160, find out the maximum UDL. So they are saying that we are having a simply supported beam. For this simply supported beam, we have 5 meter length and UDL loading. So my dear, you are talking about maximum bending stress. For that, you will be talking about maximum bending moment. So bending moment for this case, everybody is aware of, is coming like this, and it is equals to WL square upon 8. So once you get maximum bending moment, you can write down the maximum bending stress. That is maximum bending moment Y max upon INA. So my dear, you need to find out INA for the T section. When you will find out the INA for T section, this is 1 axis, this is 2 axis. Okay. The centroid of the second will be somewhere here actually. Okay. I am showing the diagram separately. So I should be found out using the concept of engineering mechanics. So this is 1. This is 2. They are the individual centroidal axes of this rectangle and this rectangle. But my dear, we need to find out I about the neutral axis. Neutral axis is passing from the centroid. So my dear, if you see this distance, what will be this distance? This distance will be 125 by 2. So 62.5. So this will be how much? You know, total is 109.375. So you would be having this to be as, yes, this to be as 109.375 minus 62.5. This is the distance. So my dear, if you want to write down for this one, okay, for this one, my dear, this distance, you know, this is 12.5. 12.5. So if you see this distance, this will be 40.625 minus 12.5. So now we are going to find out I about the centroidal axis. I feel you know the parallel axis theorem. If I want to write down IGG, it will be I11 plus A1 and this distance R1 square, I22 A2 R2 square. So I11 is BD cube by 12. It is BD cube by 12. So what is the dimension? 100 into 25. 100 into 25 cube by 12. Plus A1 is 100 into 25. Plus the distance is 40.625 minus 12.5 ka square. Similarly, plus second will be 125 into 12, 125 cube by 12, PD cube by 12. Then plus 125 cross 12 into distance is 109.375 minus 62.5 ka square. This will give you the net I value. As per my calculation, they are very lengthy calculation, my dear. So obviously without calc it is not possible. So the answer after solving this, we are getting it as 73567. 567 70.833 mm की power 4. Okay, you will get this. Now, my dear, what you need to do? You are given the permitted value. From looking at this, beam will be bending like that. This is a sagging. So top fiber in compression, bottom in tension. So you can write sigma B top. Bending moment maximum into Y top INA. And that is limited to 80 into 10 to the power 6 Newton per meter square. So you will put the value and that will limit the W value as per my calculation as around 4635 point Newton meter And similarly, when you will be going for sigma b bottom, it will be mx y bottom INA. This is given actually. In compression it is 80, in tension it is 160. So we are keeping the same. This will give us W less than equals to 3443.8 Newton meter. So guys, as this is the lower one, so we will go with this value as the answer. So guys, I have given you the way how solution will be done. I feel everybody is aware why this bending moment will be this. You can find out this will be RA WL by 2. If you will find out bending moment maximum, it will be RA into L by 2 minus W into X by 2. So you will get WL square by 4 minus WL square by 8. This will be WL square by 8. Okay, the same I have done. Obviously in the paper you have to show the SFD BMD so that you can get complete 20 marks. So here target was not to tell you how exam you need to write because you have already written. This is to tell you how the question was, how the solution will be, and this is the answer I have calculated. So you can check the calculation. I hope they are all correct. But yes, the way will be like that only because they have given in the question that the bending stresses for the material are limited by these values. Okay. So you need to find out the maximum UDL that the beam can carry. So beam can carry with this much. So hope you guys understood. So goodbye guys for this session. And stay tuned with us for all kind of updates. Goodbye.